Hey everyone, welcome to another Common Lisp Study Group. I'm your host Ram Vedam with Atlanta Functional Programming. Today we'll be continuing our flac metadata build, our application development kind of workshop. Last time, this was a couple of weeks ago, just to review, we got our application running with the basic UI. We're able to, open different flac files. Of course, it isn't as full featured as other viewers, but it's good enough to at least get us through the next portion, which is a somewhat important piece of developing your Lisp applications or any application in general. That is preparing it for deployment. This is a pretty particularly important topic, and one of which I have to say I'm not as experienced as some others may be on the call, or those of you who are viewing right now. So I'm just going to give you kind of what I tend to do, and kind of give you a survey of the space of what tools are available, so that you could try out a couple of things, and maybe there's a couple of things that you are familiar with and you'd like to present. You're more than welcome to come and present and check it out. So this is going to be based. This is somewhat opinionated, of course, just because, like I said, it's something that I'm not as experienced as others who are probably watching or listening in. Start off, the ecosystem for builds and build systems inside Common Lisp is somewhat a recent thing. Now, ASDIF has been around for like almost, I think now it's about maybe 15 years since at least last time. I've actually been introduced to ASDIF around 2005, 2006. So it's a fairly well mature system that allows you to set up your system definitions, provide dependencies, provide just a form of documentation of what is needed to set up your Lisp image and actually compile your application. We've actually generated this, although I'm not sure if other folks have actually looked at it in detail, so I'm just going to bring it up again for review. ASDIF creates, specifically if you're using project generators like CL Project or Quick Project, they'll generate an ASDIF file kind of like this, where you have a separate system definition for your tests and a system definition for your actual build. Here, as you can see, we have our system definition for our flac demo, of which we specify depends on our components. Components are your actual source files that need to be compiled. You have the option of specifying whether or not it can be compiled in parallel or in serial. The dependencies tend to be listed in the order in which you want them to be loaded into the Lisp image. This is necessary so that symbols are actually available in the Lisp image prior to certain pieces to be compiled. Sometimes there are different practices on actually dealing with packages and stuff. I won't go through those here. Really, it depends on the project generator and your own experience with dealing with Lisp projects as to what some of the best practices are. But in general, this system definition will stay fairly constant, and you can deal with that at the source code level. One of the things that are kind of nice about ASDIF with this kind of design, and of course I'm talking specifically about the CL project design approach to generating these kinds of projects, is you have this ability to specify orderings of tasks, and those are specific ASDIF tasks that you would like to execute prior to a particular operation, such as building a final executable, from happening. We've never actually leveraged this, primarily because in this particular demo we do not have unit tests. Now, this is not standard software development practices. We'll come up with them. There is going to be another follow-up application development workshop that would go through some of this stuff, which will include dealing with continuous integration, setting up your CI system to actually build in your Lisp libraries and applications. But today we're going to be concentrating on mainly building of binaries. We've talked about ASDIF in the past, and I know this might be a review for folks who have actually watched that episode and or for folks who are very familiar with it. But ASDIF itself is not it's kind of like make or CMake. It is a build system. It does not deal with dependency management or package management or downloading dependencies. Additional tools were built on top of the system to get those dependencies to follow, the ASDIF registry model, so that you can get your dependencies from the internet prior to actually compiling your application. The most successful of these tools has been QuickLisp, created by Zach, and it's heavily used in a lot of. It's actually kind of the de facto package manager for Common Lisp, and replaced a lot of the additional build utilities. It is kind of a combination of QuickLisp plus ASDIF that gives you the ability to really work through your Common Lisp images now, and makes it really convenient to actually download and try out different libraries and packages. One thing, though, that QuickLisp does not do is it doesn't actually generate executables. Like I said, it's just an additional thing that downloads dependencies and handles dependency management for you. ASDIF actually goes and sets up the Lisp image for building. So what is missing here? Really, at the end of the day, what ends up happening is it depends on the Lisp that you are using as to what you would use to create an executable. Now, excuse me for a second. Now, in Lisp land, building an executable is somewhat different than building an executable in compiled languages like C or C++, or even the most recent successes like Go. And those of you who are coming from Golang, I will also mention that the Go build tool, although it looks like it's doing both dependency management in terms of downloading dependencies and compiling, internally it actually has two additional extra tools that it leverages to actually do both. And so it has a couple of libraries that it does to actually go and handle that. But we'll touch base on if there's possibilities of doing that kind of thing in the Lisp world a little bit later. In the Lisp land, compiling an executable really means dumping an image. And what that means is you're loading up a vanilla Lisp image, all your dependencies, all your libraries, your executable code, that is the code that you've written that's part of the application. And once that's all loaded up, you call your Lisp implementation's equivalent to what SBCL calls save Lisp and die. And save Lisp and die, and I'll just show this to you here. I think it's what was it? Save Lisp and die. If you look at I'm sorry to my viewers here. Just give me this 1 second. Decide that. Hangout sometimes does this. Save Lisp and die has a couple of things. It gives you a file path name, the top level initialization. Usually, that top level is what is the entry point to your uh, application, like what function in your Lisp image should it call to in order to start up the application, whether or not you're creating executables, some runtime options, root structures, and so on. And the last option, of course, being whether or not the executable should be compressed. Now, this is specific to Steelbank Common Lisp. Each Lisp implementation has their own set of command line arguments and things that you would use to go and build in binaries. Now, I, from my own experience, have mainly used this in the past to build command line tools, building pure applications with Common Lisp, like that is applications with the UI. I haven't had much experience with, which is why I'm kind of excited that we're trying out this a little bit of an experiment today. But I'm going to show you what I tend to do when I'm building these small little tools, so that way you have at least something to start with. Save Lisp and Die actually does not create a Lisp agnostic image. It's very, very specific to the Lisp implementation. So in this case, Steelbank Common Lisp. Your Save Lisp image is equivalents in your other commercial Lisps or even other open source Lisps may have different ways of handling creating applications, and that includes, especially in the Mac world, the differences between creating Unix executables on Mac and creating application bundles. If I'm not mistaken, I've seen somewhere, although I haven't tried, I've seen folks being able to create proper bundles on the Mac to actually go in and compile their applications. We're going to focus mainly on building Unix-style executables right now, since this kind of matches both Linux and Unix, and more importantly, I'm not as familiar on the Mac bundle side to actually give an opinion. So what options are there then if Save Lisp and Die is Lisp specific, Lisp implementation specific, for you to build or create a build file, so forth, in such a way that folks can, regardless of which Lisp that they're using, they simply run a command and then build an executable. You have about maybe two options there. One option is a tool that's been around for a while. Zach wrote it. I'm not, again, as familiar with this tool, but I'm just going to mention it here. It's called Build App. Build App is available. I think the latest release was 4 years ago. It's fairly stable. All you need to do is provide your Lisp implementation and the list of load paths, and it will go in and compile your Lisp image. I tend to use Roswell for this, and I will show you a Roswell file that you can generate to build this. So to begin with, let me first do this. Let me open up a shell. Shoot. So, so you might see flac demo.ros. That's the Roswell demo that Roswell build file that I created. But it isn't actually a build file. So what Roswell does is Roswell was designed to allow you to use Lisp. Both has, whatever development language you'd want, plus has a scripting language. You could actually go ahead, like other like Python or Perl, you could actually write shell scripts in Common Lisp using Quick Lisp, and it ROS gives you this nice little script that you could then just build up. When you do generate this, it'll then execute your code as if it was a normal, Lisp image. It'll start up a Lisp image, get all the dependencies, and then execute the script. To generate this, and I'm just going to show you briefly what the commands are here. When we do a second. My apologies. I just recently updated Roswell this morning, so it's going to take just a second here. Roswell just came out with a new version, I think a month or so ago, and I forgot to update it. Longer than I expected. Give me a second here. Let's see if this weird. Roswell core. I have this strange feeling that my shell got locked up. Give me a second here. I'm going to switch to this guy behind the scenes and do some crazy magic. Let me see if this starts up again. There we go. Okay. So the Roswell utility has a bunch of different options, as you can see. The one that we're specifically going to be focusing on for writing build scripts, like I usually use it for, is ROS-init. ROS-init actually generates a brand new ROS file that looks kind of like this. I tend to name them, by the way, as .ros as the file extension, but I don't think Roswell, if I recall, does not actually specify any sort of file extension. So do whatever is comfortable with you, but I'd say settle on a standard like .ros or something, so that folks can actually know what tool to use when building these kinds of things. This file actually is a fairly simple file. What ROS generates, it's literally a shell file. You can run this guy as is, and if you change its executable to being to have executable permissions, this will load up whatever your default Lisp is has configured by Roswell, and it will then load up Quick Lisp, load up your dependencies, and then execute the file. Now, of course, for shell scripts, I should warn you, if you use Roswell for this, the more dependencies you have in your script, the longer it may take. Just primarily because Roswell always loads up a new Lisp image with all those dependencies before executing the code in question that's defined in your main function here, as it is in line 17. Now, this is if you use Roswell as a script. Roswell scripts has actual shell scripts. What I tend to use Roswell for, and this thing is I set up my entry points into Roswell, and then I run ROS build, as you can see right there. ROS build does the same thing as if you run your script, but the difference is it loads up the Lisp image and then does a save Lisp and die. it will actually, in that light, create essentially an executable for you. So how does this kind of look? So what I do is since I named the thing flac demo, if I do a ROS build here, what the heck? Something is going on. My shell is not being happy with me. Okay, give me a second, guys. I'm gonna go and switch over to the my terminal application. Yes, thank you. I know you guys can see it on the Hangout call. I just need to change OBS to share my desktop. All right. So let's go to as well. Modular local projects, AFP flac demo. Okay. So let me blow away the old flac demo here because that's what we're going to be building up again. All you need to do, like I said, when you're running this, is you just simply do ROS build flac metademo.ros, and what it does is it will start up a new Lisp image, as you can see here. It will load up your ASD file that you specified, and then it will just generate an executable for you like this. Now, what is this ASD file that it loaded up? Well, that's whatever you specified in your ROS file, which is right here. You can load up multiple dependencies here, multiple scripts, whatever. But the bottom line is whatever you load up in here, those are the packages that are going to be loaded in to your Lisp image before it compresses it. One of the nice things about this is that way, in a sense, whatever you're using, your application entry point, this becomes kind of a documentation of you loading up your dependencies in a separate light than your ASD file. Your ASD file defines your libraries and stuff. This is actually just specifying your entry point. So you don't necessarily need to use save Lisp and die with those command line options. Roswell will figure out, and it configures it so that it always uses main as the main entry point for your executable. This gives you some flexibility to have, I wouldn't recommend this, multiple entry points inside your Lisp library or Lisp applications. Like we could have certainly, made this into a command line application, for instance, by instead of calling our flac metadata main, we could have simply exported, and I'll just show this to you. We could have just simply exported in our main Lisp read flac file, and read flac file, and then obviously generate a command line version of this in the same sort of code base. Now, if you do tend to want to have the same code base, having like a CLI interface plus a main interface and different Roswell scripts, determining, based on those Roswell scripts that you're building, whether or not you're building the CLI tool or the GUI tool, you could certainly do so. But from a code maintenance standpoint, I would recommend, if you do that, to have separate files indicating one is for the command line interface and the other one is for the GUI. So this way, folks who are maintaining your code can actually go in and take a look at those issues. So let's see what gets generated here. This generates a standard Unix executable here. So if you just run this as any command here, this pops up wish. This is just like before. It's going to pop up wish and then open up our application. That's not a function of the common Lisp, but it's the function of using the Lisp toolkit to actually go and load up your UI, because Lisp LTK, what it does behind the scenes is it opens up a socket session between the Wish shell, Wish is Tickle TK's main shell, and Lisp, and it communicates commands directly to Wish to generate your UI. I haven't actually figured out, based on my reading up into on this, if there is a way to actually hide that, like Python does. That's something that I'm still investigating to see. But again, that's actually a function of the UI toolkit that we leverage to actually build this application versus building the application itself. Are there questions? Questions from our YouTube live stream viewers? Okay. And like I said, this is our standard application that I demoed to you guys last a couple of weeks ago. I haven't really changed much about it. This is going to go and gives you some information regarding the metadata application, and of course when we go and exit the application, we can exit the application. To package this, you could do a couple of things. Like in this case, this is a simple binary, so you could totally just zip it up and throw it up somewhere in, like, say, if you have GitHub, you can actually upload your zip files or whatever, packaged artifacts. It has tagged releases, just for folks to download. But Lisp alone does not provide, at least from what I've seen, any sort of packaging utility, like an installer. You would have to generate that installer using an external tool. And of course, there's a plethora of tools that allow you to generate those installers. None of them, as far as I know, are Lisp specific. They're just specific to actually building up actual installers if you really want to go down that path. But in terms of actually packaging and in creating those kinds of things, Lisp itself does not provide, at least Common Lisp, I haven't seen any tools that will provide you with the ability to package those things. Now, I'm not saying that that's necessarily a bad thing. It gives you a little bit of flexibility to use existing tools, since we actually have a compiled executable now at our fingertips. Those of you who are using Qtools, I would love to hear how you would end up packaging your applications to create Qt applications using Qtools and Common Lisp. That's something I've been investigating in my free time. Of course, one of the things that that's been frustrating for me is the fact that Qtools is still not at Qt5 yet. But I understand that getting that up to Qt5 is a large undertaking. But I'm sure that in that space, Qtools has provided some excellent ways of actually being able to create executables and binaries, because they actually have some ways of actually building out, at least I know, command line applications that you could then leverage as part of that environment. Other build tools that I could briefly mention here is there used to be older tools. If you're in the space of looking at like legacy applications that are built within the last decade, One of them that I used to use before I switched over to using Roswell almost exclusively was CL Build. Um, Now, CL Build I think has been outdated. I can't actually even find the project online. I think it's completely been deprecated. If folks know where CL Build is located, I would love to see the source code on that. Um, but the Kitorius repo that's on commonlisp.net is no longer available. Last night I was trying to actually access it, and it actually gave me a 404 not found. Um, I think it's important to realize that whatever build tool that you guys end up using, and this is a very important thing, you need to make sure, like Roswell or like Build app, that you write your scripts in such a way that they are maintainable. In Roswell's case, this is pretty obvious because flac demo. My apologies. Flac. Thank you. Because its script does not act like a replacement for ASDIF. It's actually a complementary tool that builds on what ASDIF provides in terms of system definitions and Quick Lisp as well. If you're going to use Build app, I think I currently do not have the experience to actually go and present on it. I'm mentioning it here because it is an older tool and it's probably even more mature than Roswell and provides some functionality that Roswell may not have in and of itself. Because, like I said, the script that I showed you was me leveraging Roswell as a build tool because it allows me to try out my executables prior to actually building them, and more importantly, it was an easy way to actually get without too much like investigation, getting something running that is Lisp agnostic, and that was something that I was looking for when I was actually trying to find ways of compiling my Lisp applications. Questions? All right. I really don't have much else to say about this, just mainly because, like I said, it's trying to find the different build tools and actually trying to compile them. I was able to find a couple of tools for dumping Lisp images, mainly Build app and Roswell, but I was not able to find ways of packaging applications if you want to have resources added to it. How do you set up a resource system? If you're using QTools and Qt, you would almost more than likely do that as part of building your Lisp application just by using the Qt resource system through QTools. In LTK's case, since we weren't actually adding any sort of external resources to this application, like icons for loading up the application or creating a bundle where you can have some flexibility as to not only providing where the application goes, but also additional things for configuration and sandboxing in the Mac environment. I could not find a particular tool that will do it all. And this space is still somewhat unexplored as far as I can tell. I haven't seen what different folks are doing in terms of both application development, building, and packaging. A lot of times, what ends up happening is in this space is you end up going to the Lisp implementations toolkit and seeing what it has available to you. And what I mean by that is some of the commercial Lisp tools, whether it be LispWorks or Allegro from France, both of them provide a way of if I'm not mistaken, they have a way of packaging your applications so that they're ready for deployment. So you can actually, with a single click of a button, have your package ready. I think even in the mobile space recently, and I'm hoping more knowledgeable people could make a comment on this. Mocal is another place that a commercial Lisp that does some of that, but that's doing it for iOS and Android. Um, if you want to build a common Lisp application for iOS or Android. Um, in terms of open source ones, though, I'm not familiar with them. I could not. I tried doing some digging this past week. It looks like the space has still been fairly down to like maybe a couple of tools, one of which is what I just showed you. Build app is there. And CL build used to be part of the game, but I haven't seen it being used recently. If there are other tools that present themselves to you guys that does some of this work, let me know. But I thought I could at least give you guys some way of setting up your systems for quick development, so you could write out and build up your applications quickly. But this is not the end of our application development workshop series. We have yet to talk about things that are very important for professional development, mainly things like setting up your CI system for building up different on different Lisps, and setting up using that to create your artifacts on a project. So if you use, so the needle pin pointed out something about from our past episode on using entry point RV hello program. You could certainly add that to your system definition and then do a save Lisp and die. But I've been focusing mainly on Lisp agnostic ways of, and what I mean by Lisp, it's not specific to any Lisp implementation way of actually building your program. Of course, using entry point and asdiff can certainly be used in multiple Lisps, but I don't believe what I showed you in Save Lisp and Die that you can leverage that in the command line app in the actual execution of this function. That's specific to if you use asdiff and you what's the command? Let me actually go back to that project because I do have that still. Local projects. This. Yeah. So in this one, as you can see, this command, RV hello program specifying the entry point, will be used when you do save Lisp and die with the Lisp image being available at the time, but that's after you load this guy into your Lisp image. If you're trying to do this outside of your Lisp image, and what I mean by that is if you're loading up your ASD and you're executing it, okay, you need to still have an external script to actually go do that. It'll still know where the entry point is, but it will not know how to actually load that entry point. It will, unless you have an external script to actually tell Lisp what to load. So we're talking about defining your application, which is what asdiff does, and then we have separately now that we've defined the application, what our entry point is, how do we tell a vanilla Lisp to load this guy up and then dump itself out? Because a lot of times when you're writing a Lisp application, because Lisp is an interactive development environment, meaning that you're actually, but it's not like Clojure in Python. A lot of folks, when they think about interactive development environments, they're thinking in the sense of Clojure and Python, where it takes some code and interprets it and executes it and spits out some output. But in the case of Lisp, Lisp actually follows an older model that the only other language that I know that follows this model is Smalltalk, and that is Lisp acts like an operating system. It loads up all of its dependencies into the same process memory. And when you are defining functions and defining symbols and even defining classes if you're using clause, you are modifying the Lisp image itself. That is the process that's actually there. So when you're building an application, you are actually going to want to start a brand new Lisp image and dump it, not take your current Lisp image and dump it, mainly because you may not want certain libraries to be available in your Lisp image. One prime example of that is if you're using do Emacs with Sly, because Sylvester in your Lisp image, it starts up a Swank server so that it could communicate commands that you're writing from your editor. So when you're building your Lisp image, you don't want Swank. You want to start with just a vanilla Lisp image, maybe with Quick Lisp, so that it can load all your dependencies and then dump it. This way, your Lisp image with the executable itself will only have what it needs to run your application, nothing else. Does that make sense?
Yes.
Okay. So I'm pointing that out to most of the viewers, that there is a difference between developing the Lisp application and building the Lisp application. I think it's important to know. So then needlepin. Yes, that's correct. Then needlepin. No, that's fine. No worries. Our YouTube viewers asking a follow up to this question, saying, so using ROS build will create a binary that loads your project main function to develop a binary. Yes, that is correct. That is absolutely correct. ROS build essentially takes your script, your build script, and generates a binary from that. I think it's probably one of the most useful ways of actually setting up your projects, at least from my experience. Again, you can also use Roswell. That same build script has a shell script if you wanted to, but the trade-off of doing that is, as I mentioned earlier, it will load up a brand new Lisp image and then recompile everything. Now, that may not be a problem if you are using the same Lisp that you loaded before. So if the FASL files have not, and the versions haven't changed from the last time you recompiled your image, loading up an image is pretty quick. But if you decided at some point that, you know what, I'm going to upgrade to a new version of SBCL, and you run script, it's going to reload everything. Yeah, I like your comment too. That's the reason why I then Needlepin responded saying, "Smart way of going at it. I've only used Roswell as a manager of SBCL, but never used it as a sort of a build system." Yes, that's actually when I encountered that and I saw that that I could do that. I decided to stop writing shell scripts, which is what I used to do to compile Lisp applications. Just because I wasn't familiar with build app at the time, and I was more familiar with just writing up a dirty shell script anyway to actually do this. So some of my earlier command line application projects that I used to work on to twiddle around with Lisp were almost always including a build.sh to build your Lisp application. Other questions? All right. That's actually all I had for today. It's going to be kind of a short episode, but my plan is starting next week. We go back to our fourth compiler. I'm sorry that I haven't been able to start doing some more of these on Sundays, just mainly because work and life kind of like came into play as it normally would. Hold on. There's one more question. You see your ROS script build? Yes. Okay. So very quickly, AFP metadata. So this is the Roswell script, then needle pin on how it looks. This is generated when you do ROS init on the shell. And the main things is this command here, right here, is the way that you can actually go and execute your specific, Lisp implementation in question. It'll go and query the Lisp implementation, and then use that to go and execute the script. Then this prog-n here mainly ensures that you have asdif in the Lisp implementation of your choice, and it will load quick Lisp first before it will generate a package and load up your application or library in this case. So your applications are Lisp libraries with exported symbols for main entry point. And here it generates your own main, but you could totally see it just calling, like in my case, the main that we've defined in our package on line 19. If you need command line arguments, right now I didn't need command line arguments. You could certainly turn that off. Package.lisp. I did not. I used a project called CL project to generate my Lisp projects. That was made by the guy who wrote Roswell, and it follows the pattern of the package is defined. Each Lisp file in your code will be its own package. Now, this is a fairly newer practice. Some folks in older libraries, more mature libraries, tend to follow the practice of having a package.lisp to hold all the packages that are defined in the project itself. They might even split that up into different packages based on the submodule that they're building, if so to speak. And in there, I would say that it's really a taste. It really is personal taste as to what you want and what your preferences are. I don't know which one is better. Coming from other languages where the file is the package, I was used to it, so I was like, okay, I don't have a solid opinion on it, but I'm sure other folks might have some thoughts. Folks on the Hangout, do you guys have any thoughts on package.lisp versus package per Lisp file?
about it. Just what you tell me.
Yeah. How about you, Richie? Do you have any preferences on that?
Not really, no.
Yeah, I figured. I really don't know what the right answer is on that. Yeah, Layla. Yeah, Layla Howe is commenting on my dev environment, and yeah, thanks for the shout out. I started using Doom Emacs just recently, so it's I'm still getting used to it. I was coming from Space Max, so the key bindings are still messing with me, and but it's a learning experience. Once you start learning, the key bindings, it just becomes muscle memory. The one thing I don't like about Doom Emacs and even Space Max has this problem is the shell isn't as full featured as I thought it would. I think that requires a little bit more work. I think this is just a problem with the Emacs shell. But I have noticed some weirdness when I run the Emacs shell.
If you compile with modules, use Vito.
Say that again. I didn't quite hear you.
If you compile
Mm-hmm.
Emacs with the modules feature,
Mm-hmm.
then you can install vterm, which is a full-featured shell.
Oh, nice. Okay. So, but I have to compile it myself instead of it's not part of the binary installation.
Whoops. I guess it depends on the back, because I use Emacs-Mac, and you have the option to brew install that with -- modules option.
Ooh, sweet. Okay, I'm gonna write that down. Yeah. Brew install Emacs-Mac. You said.
Yeah,
And
it's a tab.
and what module do I need to install? Out of curiosity.
Once you compile Emacs or build it with the -- modules option,
Mm-hmm.
then from Melper you can install vterm.
vterm. Okay, sweet. Okay. All right. And I appreciate all of you joining this Saturday. I know it's a lovely day outside, but given a lot of things happening around right now, I'm sure some of us are still in the shelter in place. Hope all of you are staying safe during this pandemic. And I will. The plan is again, like starting next week, we're going to go back to doing stuff with Fourth, and I'm still trying to figure out a couple of new ideas and talks. Any thoughts from our viewers? Ping me on Discord. I'm Bugram on Discord, and I'm on the Functional Programming Slack server all the time, pretty much. Usually just squatting in hyphen Lisp there. If there's any questions, thoughts, comments, projects, ideas that you'd like us to go through, let me know. I am planning on just letting you guys on the Hangouts know. I wanted to know your. I'm. Have any of you started reading that Lisp implementation book by what's his name? Forgetting the guy who wrote Scheme from user Scheme 9 from user space. Because I was thinking about purchasing that.
Niels Hom?
Yes. Yeah. Have you read that book yet or checked it out?
A long time ago.
Yeah, I just purchased functional data structure, purely functional data structures by Okazaki. So I'm going through that right now. But I was thinking about writing, trying to get that one or Lisp in small pieces so that we could start going through some Lisp implementations. but I was hoping to hear if you.
I'd probably be better off with Lisp in small pieces, since that's the one that like everybody recommends.
Yeah.
I think the other one is, I have a copy of it and I looked at it, but I haven't had a chance to read it. I think it's more along the lines of like the Scheme 9 implementation. It's just like, it's all in C, and it's a lot of, I guess, detail about his particular implementation versus like I would say probably like an overview of like how to potentially do something for Scheme or Lisp or whatever.
Okay. Yeah, I thought so. Lisp in small pieces is a very, very involved. It uses. I browsed through the book, and they go through like 17 different interpreters. So you're building like different Lisps at each level, but it's a very nice little overview of all the different ideas in available in building your own Lisp and designing your own Lisp. So I thought it's something that we may want to start covering, especially since we're covering fourth anyway. May as well get the coverage on the Lisp side too for writing compilers in Lisp. So stay tuned for that, folks watching, and I'll talk to you guys next week.